Yeah, very good morning to one and all. And here in this class, I am going to deliver about various phases of the compilers. And all of you see the slide that I shared to you all. See here. Here we're having six phases of compilers for process for the process that we need to carry it out by using these six phases. Yeah, see, by knowing the definition of the compiler, what the definition of the compiler is nothing but an translating from one language to the another language means compiler is just acting as a mediator between two languages, either it may be in high level language as an source and machine level language as an target. That's why we are calling that source and the target, but we're naming it as a source program and the target program. And what the definition of the compiler is, compilers are basically translators that translates from source program to the target program. That means converting from one language to the another language. See here, in between how the process of compilation is going to be carried out, that's what we're going to learn in this class. That's what we're going to learn in this class by seeing the structure of this phases of compiler and along with the brief description with an example. See here, we're having a structure. Initially, we're starting with an character stream. Character stream is nothing but a source program. That's what we're calling it as an input program. Input program. And that input is giving to the lexical analyzer, and after performing some functionality in a lexical analyzer, what the output that the output that the lexical analyzer is going to be generated is in the form of an token of streams. And here the token of stream is an output that we are generating from an lexical analyzer. And what the output that we are generating from the lexical analyzer is stream of tokens. We can call it as a stream of tokens. And that's what we are going to generate from the lexical analysis. And now this is the first phase of the compiler by taking the input program. By taking the input program in the form of character of streams. And after performing the lexical analysis, what we are going to generate from the lexical analysis is stream of tokens. Make a note of all this. Stream of tokens, and this stream of tokens is acting as an input to the syntax analyzer. Input to the syntax analyzer. And now by taking the tokens, by taking the stream of tokens from the lexical analyzer, and now by performing an syntax analysis, then what type of an output that it is going to be generated is syntax tree structure, that we can call it as an hierarchical structure, tree structure, syntax tree, the syntax tree that we generated from an syntax analysis. And now this syntax analysis is acting as an input to the semantic analysis. See here, we're not taking an input from again from the character of streams for the syntax, again from the character of streams from the semantic. We're not taking from the character of streams. What we're taking an input, we're taking an input of previous output. Whatever the output that we generated in the previous phase, that output is taking as an input to the current phase. Make a note of this. This is nothing but an pre-processing technique. This is nothing but an pre-processing technique. And now by taking an input in the form of an syntax tree, now after performing the semantic analysis, what the output that we're going to generate is, again it is in the form of a tree structure that we can calling it as an syntax analysis, syntax tree. But what we are doing in a semantic analysis is we are checking out the meaning of the tree, meaning of the generated tree, whatever the tree that we generated in at the time of syntax analyzer, that we are checking out by using the semantic analysis. By using the semantic analysis, we are checking out whether the tree structure is in an correct format or not. And now, and the next phase is, and this is a third phase, semantic analysis is a third phase of the compilers. And the next phase is an intermediate code generator. Now I want to implement an intermediate code generator. And I am taking an input from the semantic analysis. Whatever the semantic analysis that is generated in the form of an output, that I am taking as an input to the intermediate code generator. And now I am performing some intermediate code representations, having so many representations, but here we are choosing one representation, that is an 3 address code representation. And by performing the 3 address code representation, the output that we are going to generate from this ICG is nothing but an intermediate code generator. The output that we are going to generate is an intermediate code representation, where we are storing it in an temporary variable, storing by using the temporary variables, storing the tokens by using the temporary variables. And that we are calling it as an intermediate code representation that we are generating from an intermediate code generation. And after performing the intermediate code generation, we are generating an representation of that code. So this is taking as an input to the code optimization. And how the code optimization is going to be done? By performing the optimization techniques, we are going to minimize the lines of the code and improve the efficiency of the code. That's what it is going on. That's what we are implementing in a code optimization. What we are implementing in code optimization, by applying some transformation techniques of code optimization, what we are doing is minimizing the lines of the code and improving the efficiency of the code without changing the meaning of the code. And again, the representation, the output that we're generating from the optimization is same as an intermediate representation. But what is the difference from the intermediate code generation output and the code optimization output? Here just we are minimizing the lines of the code, but the code is same. Code, whatever we're generating in the both phases are same. But here, for example, we're having some 10 lines of code. After applying the code optimization technique, we are minimizing the 10 lines of the code into or 8 or 7 without changing the meaning of the code. Without changing the meaning of the code by applying some transformation techniques. And see here, in the second phase in syntax analysis, we are generating a syntax tree. And again in a semantic analysis, we are generating a syntax tree. But what is the difference between these two phases? Here we are giving the structure of the generated stream of tokens, giving the structure, grouping together to form an hierarchical structure, and taking this structure and we are checking out whether everything is in correct format or not. What it means is checking out the meaning of the generated tree structure, checking out the meaning of the generated tree structure. Same as here in the intermediate code generation, we are generating an intermediate code representation in a 3 address code format. Again, by applying the code optimization techniques, the output is also in the form of a 3 address code format. But what is the difference between in these two phases is, there itself we are just storing in a temporary variables. We are not uh, we are not considering about how many lines that we are getting from here, how many lines that we are generating. But while coming to the optimization to improve the code efficiency, we are considering the efficiency. Here we are considering the constraint like an efficiency. So to improve the efficiency, what we are going to do, we are minimizing the lines of the code without changing the meaning. So from the intermediate code generation, whatever the output we are generating, the representation of the output is same as the representation of the output from the code optimization. Make a note of all these. And then after performing the optimization, we generated an intermediate code representation, minimized an intermediate code representation. Make a note, minimized intermediate code representation. And this is taking as an input to the code generator. This is taking as an input to the code generator. Now here we're generating, and simple code generation algorithms are going to be performed in a code generator. And after performing the simple code generation algorithm, then finally we're generating a target machine code. Finally, we are generating a target machine code, which is an executable code from the given character of streams. Here we define a character of streams where it is nothing but an stream of characters. Stream of characters is nothing but an source program. And here target machine code is nothing but an target program. That means the object code, executable object code that we are generating in the form of a machine level language. And here, whatever the code that we are going to generate it should be an efficient code. How we can calculate the efficiency? How we can calculate the efficiency of the code? Just by applying the code optimization. Just by applying the code optimization. Just by applying the code optimization, whatever the target machine code that we want to generate, in the form of an executable object code, that should be an efficient code. That should be an efficient code. So make a note of this. See here, these are the 6 phases of the compilers. Main 6 phases of the compiler. The first one is an lexical analysis, second is an syntax, third is an semantic, and the fourth is an intermediate code generator, fifth one is an code optimization, and the sixth one is an code generator. See, in between we are having the another subphase. What is that? Is symbol table. Symbol table. Symbol table and error handler. These are the two subphases of the compilers. Here we need to talk about what the symbol table is. See, every phase is linked to the symbol table. We're having a representation here. See, lexical analysis is having an connectivity to a symbol table, syntax is having an connectivity, semantic, intermediate, machine code optimization, code generation, and finally whatever the machine independent code optimization. For everything whatever we are performing, the internal functionality of each and every phase should be connected to the symbol table. Why? Because symbol table here it is acting as a data structure. For the data storage we are using an symbol table. For the data structure for the data storage we are using an symbol table. This what we are making as a record of our phases of compiler. Record, making it as a record of our phases of compiler. For example, I done some functionality in a lexical analysis, and when I'm implementing a semantic analysis, if I get any doubt in the part of a lexical analysis, just I want to retrieve the data. From where I have to go and retrieve the data? Everything whatever we perform in a lexical, whatever we perform in a syntax, semantic, ICG, code optimization, code generation, everything should be stored in a symbol table. So when so by going into the symbol table, by retrieving the data from the symbol table, we can easily understand what we done in each and every phase. What we done in each and every phase. So symbol table is acting as an data structure. We are storing the data in a symbol table, storing the internal functionality or storing the information about each and every phase in a symbol table. So these are the 6 main phases, and the symbol table is an subphase of the compiler. And this is a brief introduction about various phases of compiler. And now we are going to learn in detail by learning with an example. In detail explanation by learning with an example. See, this is a structure of the compiler. This is a structure of various phases of the compiler. All of you see the slide once. Here we are having the structure of various phases of the compiler and 6 main phases and 2 subphases. 6 main phases and 2 subphases. One is a symbol table and another one is an error handler. See, the symbol table and error handler, for each it is connected to each and every phase. Symbol table and error handler are connected to each and every phase. Initially source code and finally target code. Source, target, in between the process of compilation by using the 6 phase.